Question 3. Figure 1 shows a battery operated remote controlled car, just here. The car's battery contains a store of energy. As the car moves, energy from one store is transferred to another store. Describe how the different stores of energy change as the car moves. Okay, so stores of energy change as the car moves. It's worth 2 marks. So they tell you the battery contains one store, and the car moves, energy from one store is transferred to another store. So we've got 2 marks, 2 bullet points. So the chemical store of battery, and we've just got to describe what happens to it. So it decreases, okay, because its energy is being passed from the chemical store of the battery to, so the chemical store reduces, and as the car moves, energy from one store is transferred to another. Different stores of energy change as the car moves. So as the car moves, now it might be moving at constant speed here, so we could say the kinetic store increases, but that suggests that it's not moving at all. It suggests that it starts off not moving. So eventually what we have here is the kinetic store of the car. Let's just think, so the chemical store of the car will be transferred to, and there's always, remember, multiple different things it's transferred to. But the 2 bits, we've got the chemical store here. So the chemical store of the car will go to the kinetic store, but we'll also get as well the thermal store of the surroundings. And eventually the kinetic store, it will run out of battery, and eventually it will go to the thermal store. So the chemical store of the battery increases. The thermal store of surroundings increases. So it's a tricky one here. If you started saying that the kinetic store increased, the question would have to have told you that the car wasn't moving initially. Okay, but you'll always be right by saying the thermal store of the surroundings increases whenever anything happens. The car has a top speed of 12 meters per second and a mass of 800 grams. Write down the equation that links kinetic energy, mass and speed. An equation that's worth 1 mark, so just write down the equation. Now in 2023, June 23, you'll be given the equations, so it might well say find the equation in your equation sheet, but we know that kinetic energy is equal to 1/2 times m times the velocity, the speed squared. Okay, if you wrote just the symbols down, that's absolutely fine. If you want to make sure the examiner knew that you knew what each of these things was, if you wrote symbols, you could write them above like that. Okay, that's absolutely fine. If you use different symbols, that's no problem, so long as it's clear what thing you're meaning. So don't go making up new symbols, calling mass X or anything else like that. Speed as an S would be fine. If you're unsure, write it out in full in words. Calculate the maximum kinetic store of the car. So we're going to use every. Can't I see? There we go. We're going to use every. So we're going to write down the equation first of all, which is KE equals 1/2 times m times v squared. It's worth 2 marks. We're going to write down the values and convert. We're just going to check the values. So we've got speed, 12 meters per second, mass of that. So we've got v is equal to 12 meters per second, which is fine. I'm happy with that. M is equal to 800 grams, which is a bit sneaky for 2 marks. I'm surprised that's only a 2 mark question. I'd be expecting maybe 3 because grams is not a normal unit of mass. So I've got to convert that to kilograms, 0.8 kg, and that would be worth 1 mark there. Then enter the values over here. So 1/2, I'm going to change that to 0.5 times 0.8 times 12 squared. Okay, let me just do that. So 12 times 12, 144. So 0.5 times 0.8 times 144 equals a grand total of 57.6 joules. Okay, oops. Be careful here if you're going to write down the units. They obviously tell us the units here anyway, but if they didn't, make sure joules is always a capital letter. Okay. Some people get concerned about my V. I do a V with a lowercase v with these weird little tails on the top, just so I know it's not my capital V. You don't need to do that, don't worry. Okay, let's have a look at part B. So explain why having a more efficient motor increases the top speed of the car. So it's an explain question. And explain really is just a describe plus. So what do I mean by efficiency here? Why does that matter? So more efficient motor increases top speed of the car. It's worth 2 marks. Okay, so do I know what more efficient means? Well, if something's more efficient, so more efficient means it wastes less of its energy. Okay, a lower proportion, so it wastes less of its energy store. Well, why is that important? This means more of its energy store converted to kinetic store of the car. Okay, so there's more of its kinetic energy is transferred to the car. That's the key bit. And you could have said there, less energy is wasted, therefore more kinetic energy. That's fine. The key bit is you can describe what more efficient means in terms of it wastes less energy, and then you're saying why that matters to the car.